This video is part of my complete practical CCNA course, where I'm not showing you things using simulations, but I'm actually demonstrating stuff with real equipment, such as Cisco switches, Linux, in this case Kali Linux, which I'll use to hack this network, Windows devices, and a Mac. I've also got great news in that Cisco is sponsoring this video and making labs available so that you can practice what I'm doing here yourself. Use the links below to access Cisco U so that you can practice this yourself. In the CCNA exam 200-301 version 1.1, they tell us that we need to know the root guard, loop guard, BPDU filter, and BPDU guard for the exam. In this video, I'm specifically going to show you root guard and demonstrate it, as well as BPDU guard. But again, rather than just using a simulation, I'm going to attack these physical devices using Kali Linux and a Python script that I've written. Now, you don't have to study the Python script for the CCNA exam, even though I'd highly recommend that you learn Python. What you need to know is how to use root guard as an example and BPDU guard to protect a spanning tree network. I'm going to show you those two in this video, and in the next video I'll show you loop guard and BPDU filtering. Did you know that you can join Cisco U for free and get access to a whole bunch of content? There is both paid as well as free content available on Cisco U. Huge amount of content available in their paid tier, where you get access to networking training, security training, cloud training, and a whole bunch of other training. It's not just Cisco training. You also get access to third-party training as part of Cisco U. But if you can't afford the price of Cisco U, there is a whole bunch of free training available. You can get access to various tutorials created on Cisco U. Once again, you can practice what I'm showing you in this video on Cisco U for free. I really want to thank Cisco for sponsoring this video, as well as creating labs that go with this training. So use the link below once again to sign up to Cisco U, show the love, register for a free account, get access to the free content there, as well as follow along with this video. Now back to me showing you how you can use Python to hack networks, and then I'll show you how to protect your networks from fake BPDUs sent into a spanning tree network using very basic Python scripts. So let's start with root guard. So what is root guard? It basically protects your spanning tree topology against unauthorized switches attempting to become the root bridge. In other words, they send superior BPDUs, not inferior BPDUs or bridge protocol data units. Superior BPDUs means that they have a lower priority, as an example, or lower MAC address, and therefore through the election process become the root. We want to block that. So root guard is going to block access on a port until receipt of superior BPDU stops. This allows you to protect your network against hackers, which I'm going to demonstrate in this video, or switches that are introduced into the topology that have a lower priority or lower MAC address. In other words, are going to be elected as the root bridge. Now, in a spanning tree environment like this switch could be the root as an example, and this could be the backup root. We do not want to allow switches to tell us that they are the root bridge or root switch. Remember, bridge as a term in spanning trees based on bridges that existed years ago. So we often talk about a root bridge rather than a root switch in spanning tree. So here's an example. A rogue switch is introduced into the environment, sending BPDUs, but in this case, superior BPDUs. Let's say this switch has a priority of 4096. It's the root switch or the root bridge in the topology. This switch sends BPDUs saying, I am the root bridge. My priority is 0 as an example. This will therefore become the root bridge, but we want to stop that. We want to make sure that our switch remains the root bridge. In the same way, we don't want to switch like this switch over here, this access switch telling the network that it's the root bridge. We're going to error disable a port where superior BPDUs are received. Now, there's no better way, I think, to show this than to do a demonstration. In this example, I'm using Kali Linux, which is running over here on this laptop in a virtual machine. I'm going to send BPDUs from Kali using a Python script. At the moment, this switch, the 9200CX switch in the middle, is the root switch. But we're going to say that we are the root switch by sending superior BPDUs. So in our topology, we've got the 9200 over here. We've got a Cisco 1000 switch, switch 1 over here, and another Cisco 1000 switch over here. So 3 Cisco switches. The 9200 has a Mac connected to it, and the 1000 series switches have Windows devices connected to them. But the important part of the network is what's going to happen on this port 102 on the 9200. So on the 9200 series switch, I'll go to enable mode, show spanning tree. Notice at the moment, for VLAN 1, the root ID and the bridge ID are the same. So in other words, the priority for both is 4097. That's because this switch, and I'll just type show run pipe include span to show us the output. This switch has a priority set to 4096. Increments of 4096 to set the priority. This one is set to 4096. This is VLAN 1, so the priority here is 4097. 4096 plus 1, because extended system IDs are used on this switch. So what we can see is that this bridge is the root. In other words, this switch in the middle is the root switch. We can see that all ports are designated ports, all ports are forwarding. We would expect the root switch or root bridge to have all ports as designated ports and all of them forwarding. So again, show spanning tree, local switch is the root, priority of the root and bridge are the same, MAC address is the same. Okay, but on Kali Linux, which is connected to gigabit 102 on the 9200, we're going to send BPDUs. So ls on Kali, I've got the script, spanning tree roothack.py. I'm going to run the script so that you can see what happens, and then I'll talk a bit about the script. Again, you don't have to learn the details of the script. I'm basically using something called Scapy to create packets and inject packets into the network. So sudo python 3. I'm using Python 3 in this example, and the Python script that we're going to run is spanning tree roothack.py. Before I run that, again, show spanning tree. Notice this port, gigabit 102, is a designated port. It's forwarding. The local switch is the root switch. Okay, so run the script, put in my sudo password. Something happens now. You can see packets are being sent into the network. Previously, gigabit 102 was a designated port. Show spanning tree now. Notice gigabit 102 is now root port. It is forwarding, but notice the root switch has a MAC address of a bunch of zeros and a 1. I don't know about you, but I think that's a little bit suspicious. Which device has a MAC address of all zeros and a 1? And notice the priority is set to 0. In other words, Kali Linux has now become the root switch in the topology. Again, gigabit 102 is the root port of the 9200 series switch. In our topology, this port is a root port, indicating that the root switch of the topology is Kali Linux. By running a simple Python script, made Kali the root switch of our topology. So again on the switch, gigabit 102 is the root port of the switch. It's no longer the root. The root has a priority of 0 and a MAC address of 1. What I'll do is stop the script on Kali, on the switch, show spanning tree, still showing root port. Give it a bit of time, and as you can see, it's now become the designated port. The switch has now become the root again, whereas previously it wasn't the root. If I run the script again, switch was the root, no longer the root. The root is now Kali Linux. So by running a simple Python script, I'm able to change the root switch in a spanning tree topology. This is what the script looks like. What I'm doing basically, and again, you don't need to know the details of the script. I'm just showing you this for interest's sake. You can get the script on my GitHub. So I have put the script on my GitHub using this link, or you can just search for David Bombal GitHub and you'll find my Scapy scripts. What I'm doing is importing Scapy. Scapy allows you to create or forge packets of any kind, if you like. So you can put layer 3 above layer 4 as an example. You can mix your layers up. You can do all kinds of interesting things with Scapy. Create packets that shouldn't be allowed on a network. But in this example, I'm importing Scapy, and then I'm going to capture a spanning tree packet. This is the destination MAC address for spanning tree. So rather than creating a frame from scratch, I'm going to capture this frame off the network with a destination address of this. And then all I'm going to do is change some values in the packet. So I'm going to change the source MAC address to be this. So when the packet is sent into the network, we can actually view the packet that's sent out. At layer 2, the destination MAC address is the spanning tree protocol, but I've changed the source to be a bunch of zeros and 1. So that's the source MAC address. LLC has values that haven't been changed, And this is the advantage of capturing a packet and then manipulating it when you send it out, because you don't have to create all the layers. But notice the root MAC address is this and the bridge MAC address is this, because in the packet, I'm saying root MAC address is this, bridge MAC address is this, and I'm setting the root ID to this and the bridge ID to this. So I'm basically changing all the fields in the packet to ensure that my Kali Linux machine becomes the root. So root ID is that, bridge ID is that, MAC addresses are set to a bunch of zeros and a 1. I've set the port ID, age, max age, and other timers I've just left at default. Again, one of the advantages of grabbing the packet off the wire and then just making changes to it is that your packet or frame is a legitimate packet or frame, and you're just changing some values rather than having to recreate the entire packet. So again, you don't have to know this for the exam, but there is my simple Python script. I'm showing the frame, and then I'm creating a loop where I send 50 packets into the network. So I'm sending the packet into the network, waiting a second, and then looping. So every second, just send a BPDU into the network saying that I am the root switch. And the net result is, once again, show spanning tree on the 9200. It has this port as a designated port. It is the root switch. But as soon as I launch my script, it captures the packet off the wire or frame off the wire, manipulates it, and sends frames into the network. The 9200 is no longer the spanning tree root. The root becomes Kali. You're going to want to stop this kind of nonsense. And the way to do that, again, is to use root guard. So I'll show you how to set up root guard first, and then I'll show you demo 2, where a switch has a lower priority and becomes the root switch. Okay, to enable root guard, you do this on a per port basis. So you go into global configuration mode, and then on each interface or each port, in this example, gigabit 101, or for this specific example, be 102, we enable root guard by using the command spanning tree guard root. So simple as that. To set this up, if you type show run and a interface such as gigabit 101, you'll see in the output that that command has been enabled on your interface. So before continuing with slides, let's actually do a demonstration so we can see what's happening practically. So on the switch, conf t, interface, gigabit 102 in this example, spanning tree, press question mark, guard, question mark, root, question mark, enter. So all I have to do is type that command on the interface, and as you can see, root guard has been enabled on that interface of the switch. Now in my topology, I also have an interface to these two switches, so I could enable spanning tree root guard on both of those ports. So let's do that while we're here. So I'll press up key twice, go on to interface gigabit 103 and enable spanning tree guard root on that. Go on to the other interface, gigabit 104, and enable spanning tree guard root on that interface. Okay, so that may not be so clear, so I'll type show run pipe begin gig. And as you can see there, in the running configuration of the switch, this interface, and this interface have spanning tree root guard enabled on them. Okay, so let's see what happens when Kali Linux sends BPDUs into the network. So I'll clear the screen here and type sudo and run the command again, sudo python spanning tree root hack. Packets are now being sent into the network, and notice straight away on the switch it says spanning tree root guard block. Root guard blocking on port gigabit 102 on VLAN 1. So show spanning tree now. Notice we've got a root inconsistent output. Notice on gigabit 102, it says blocking for VLAN 1, root inconsistent. So this is done on a per VLAN basis. For VLAN 1, that port is blocked. You can see once again in the output that it was blocking on VLAN 1. And notice now it says unblock on VLAN 1, and that's because BPDUs are no longer being received. So the port is now moved to the learning state. It is now a designated port and should transition to the forwarding state after a period of time. So it's learning and then should go forwarding, which it's now done because no BPDUs are being received. That's because Kali only sends 50 packets and then stops. But if I run that again, notice port is now blocking again. So shows spanning tree, this port is now blocking. Port is marked as a root inconsistent. Okay, so what triggers root guard to block a port? So the trigger is when a superior BPDU is received by the switch on a specific port. The port is then put into the broken state for that VLAN. So I said blocking, but it's actually seen as broken. All traffic is discarded. The port state is root inconsistent, as we could see over here. Notice broken, root inconsistent. By default, the port is restored after a period of time when superior BPDUs are no longer received. And that's what we saw here. Notice root guard unblock, port is unblocking on gigabit 102 in VLAN 1 because no superior BPDUs are received by the switch. Now you can use the command show spanning tree inconsistent ports to see which ports are in the inconsistent state. So at the moment, show spanning tree looks good. Show spanning tree inconsistent ports now. You can see no ports are inconsistent at the moment, but let's change that by running our script again. So you can see that root guard is blocking the port. Show spanning tree inconsistent ports. This port, gigabit 102 on VLAN 1, is now root inconsistent. Number of ports in system is 1. If we look at a specific interface, so gigabit 102, you can see that for this interface, which is different to say 101, this interface is broken, root inconsistent is the current state. Now that no BPDUs are received, if we run that command again, notice it's back to a point-to-point link. It's busy learning. The role is now designated, status is learning, and that will take a bit of time, and then it'll go forwarding, as you can see over there. Send BPDUs again into the network. Port is blocking. Show spanning tree. Status is broken. Type is root inconsistent. Okay, I think I've covered that enough now. Last demonstration is to simply change one of the switches to be a root switch. So rather than introducing another switch into the topology, I'm simply going to make this switch, switch 1, say that it's the root switch. So on the 9200, show spanning tree at the moment, switch is the root switch. All ports are designated ports and are forwarding. But what I'll do on the 1000 series switch, switch 1, that's the switch at the top here. I will type spanning tree VLAN 1 priority. And in this case, I'll set it to 0. The reason why is show run pipe includes span shows me that this switch has a priority of 4096. So I need to make the 1000 series switch have a lower priority. So I'll set that to 0. And notice straight away, root guard blocking on gigabit 103. So show spanning tree again. This port is now broken, root inconsistent. On this switch, show spanning tree, it says that it's the root switch. All ports are designated. And I'll just do that command again so we can see it clearly. For VLAN 1, priority is 1. It thinks it's the root switch, but on the other side, this switch is blocking the 1000 series switch. So what I'll do is remove that command, show spanning tree now. Switch still thinks it's the root. It's now learnt that it's no longer the root. The switch with this priority, 4096, and this MAC address is the root. In other words, the 9200. The local switch has a higher priority and MAC address. So it now has a root port forwarding to the root switch. And on the root switch or the 9200, notice the port is no longer blocking because no superior BPDUs are received. Okay, so I think that's enough. I have now shown you how to enable root guard using this simple command. You do that on ports where you don't want to receive superior BPDUs. And if you do, the port on a specific VLAN is basically blocked. Now let's talk about BPDU Guard and how you can use BPDU Guard to protect a spanning tree network. Now on ports such as these two, connected to PCs, you may enable port fast. So spanning tree doesn't have to go through the different stages of blocking, listening, learning, forwarding. It can immediately go forwarding. The problem with that is what happens if BPDUs are received by clients. In that case, we want to enable BPDU Guard so that the port is error disabled if we receive BPDUs. Now a user with a PC may be connected directly to a switch, but may decide that they're going to use a switch to allow two PCs to connect to the network. In that case, BPDUs may be sent by that switch, and this switch could potentially become the root bridge. Remember, lowest MAC address, lowest priority becomes the root bridge, which means that an old switch could potentially become the root bridge of your topology. Another thing a user may do is connect 2 ports to the switch, and that'll cause a loop if you've got port fast enabled on your edge switch. So the moral of the story is don't trust your users. Enable BPDU Guard on port fast ports so that users don't, by mistake or on purpose, cause spanning tree loops or cause problems in your topology. So in this topology, I've changed it slightly. I've made switch 1 the root bridge. So this little 1000 series switch is now the root. I've changed the cables as well so that the 9200, the middle switch, is now connected to this bottom switch on port 104, and C1002 is connected to the top switch. So basically, from the 9200 series point of view, to get to the root bridge, it has to go via C1002, this bottom switch. We can see that on the switch shows spanning tree. Its root port is gigabit 104, this switch in the topology. But Kali Linux is now going to send BPDUs saying that it has a better path to get to the root bridge. So basically, we're going to tell this switch to use that path to get to the root bridge, which means it should block this port because it has a better path to get to the root bridge. In other words, it'll cause problems in the network. If this Mac sends traffic to this PC or to that PC, it's not going to be able to send that traffic successfully because this port is now blocking. So again, we're going to make this switch believe that its root port is the port to the Kali Linux machine. When this Mac tries to send traffic through the network, it's not going to work because this port is blocking. So we're going to essentially break this network. So on the MacBook at the top there, I've got it sending a continuous ping to both the PCs. On the Mac, if we do a command such as ifconfig pipe grep 192, we can see that its IP address is 192.168.1.2. It's pinging 1.1, which is this Windows computer, and pinging 1.3, which is the Windows computer at the top. Continuous ping from the Mac to those two PCs. Let's hack the network using a simple Python script once again. Script that looks like this. Essentially, what we're going to do is sniff spanning tree, destination MAC address is spanning tree. We're going to manipulate the packet to say that the path cost to get to the root is 0, and we're going to send 50 packets into the network. So, ls on Kali. We're going to block the network. So cat stp block, that's the script. Again, you don't need to know this Python script for the exam. I simply want to show you a practical example of this. So sudo python spanning tree block. Before I hit enter, notice once again on the 9200 series switch, its root port is gigabit 104, 102, where the PC is connected is forwarding and it's a designated port. So press enter, put in my password, go back to the switch. Notice the root port has become 102, gigabit 104, which was originally the root port, is now an alternate port and the state is blocking. It was forwarding and now it's blocking because the switch believes that the best path to the root is via the hacking machine. It believes that it can get to the root bridge or root switch via the Kali Linux machine, which it can't obviously. What you'll notice is pings are failing on the MacBook. The Mac is no longer able to ping 192.168.1.1, this Windows computer, or 192.168.1.3, that Windows computer at the top, because the switch believes that the way to get to the root is via Kali Linux, this computer over here, which is obviously not correct. Okay, Kali has now stopped sending traffic into the network. So hopefully what should happen is the root port should go back to 104, which it has. But notice the other two ports are still blocking because spanning tree needs to converge. So now the status is learning and eventually that will go forwarding, and there you go. Ports are now forwarding. So back on the Mac, notice pings are now succeeding. But as soon as Kali sends BPDUs into the network once again, root port is now changed to gigabit 102 and pings are failing on the MacBook. We have basically broken this network. Gigabit 104 is blocking. It's an alternate port. Root port is 102. So this port is now blocking. Root port, according to the switch, is this port. It's trying to send traffic from this Mac to that Windows computer and this Windows computer via Kali, which is obviously not going to work. We have essentially broken the network by sending BPDUs from Kali to the 9200 series switch. Again, as soon as the Python script ends, MacBook can now ping the two Windows computers. Okay, so how do we fix this? We use BPDU Guard, which protects against BPDUs received on ports where they should not be received, such as port-fast ports. The receipt of unexpected BPDUs may be accidental, someone by mistake plugged in the wrong port as an example, or may be part of an unauthorized attempt to add a switch to the network. Someone shouldn't have added a switch to the network, but they did, so we want to block those ports. So the way you set this up is on a spanning tree port-fast port. So let's say gigabit 102, where you've got port-fast enabled. We want to run this command, spanning tree BPDU Guard enable. So it's only one additional command on the port-fast port. And here you can see the output of the show run command. Notice port-fast is enabled, as well as BPDU Guard on gigabit 102. What's the trigger? Any BPDU received on that port will cause the port to be error disabled. Spanning tree removes the interface from the spanning tree instance. So interface is no longer connected to spanning tree. By default, recovery works as follows. You need to shut the interface down and then no shut it. So you have to manually shut it down and then no shut it. Or you can configure error disable recovery parameters, but by default, you have to manually shut and no shut the port. This is what it looks like when BPDU Guard is running. We see a BPDU on the port. Port is error disabled. And you can use a show command, show interface, specific interface, status, and you can see the port is error disabled. Now again, slides are okay, but it's much better to see this practically. On this interface, where our hacking device is connected, we want to enable BPDU Guard. So conft interface gigabit 102, spanning tree, BPDU, option we're going to use is guard, enable. So show run, interface, gigabit 102. I have previously configured spanning tree port-fast on this port, and we are enabling BPDU Guard. This is not relevant. In this case, I changed a spanning tree cost on this interface just to make sure that the lab worked properly. That's not needed. You don't need to configure that. These are the two important commands to take note of. So before we send BPDUs into the network, let's have a look at the status of the port. As you can see there, this interface is connected. We can see information about the speed, etc. Interesting that the speed was negotiated incorrectly. That's why I had to set a spanning tree cost. This should be showing gig, but for whatever reason has decided to negotiate at 100 meg rather than gig on that interface. But anyway, show spanning tree. That's what it looks like now. I'll send BPDUs into the network from Kali. And as you can see here, spanning tree block BPDU Guard, receive BPDU on gigabit 102 with BPDU Guard enabled, disabling the port. So BPDU error detected on this port, putting the port into an error disabled state. Interface has now changed to down. So notice interface went down. So show spanning tree, notice that interface is no longer shown in the topology. Looking at the interface, so show interface as gigabit 102 status, notice port is error disabled. Now once the packets are stopped, on the MacBook, notice no pings were dropped. So going all the way back here, sequence numbers, you can see no pings were dropped. Pings are continuing. The network hasn't broken because of BPDUs being sent by Kali. Port is error disabled. What we'll have to do is manually re-enable it. So go onto that interface, gigabit 102, shut it down, and then no shut it to re-enable the interface. So interface has now gone administratively down. No shut it. Interface has now come up. So if we look at the status of that interface again, notice it's now connected. If we look at spanning tree, notice the port is now forwarding. Interface is connected, but if someone does something they shouldn't, like sending BPDUs into the network, interface goes down. Spanning tree has blocked it. BPDU Guard has blocked the port. Interface has gone down. So if we look at the status once again, so show interfaces gigabit 102 status, notice error disabled. Again, that doesn't affect the Mac. All traffic is going through the network correctly. The port where a BPDU was received is error disabled. Status is down basically. It's no longer part of spanning tree. Okay, so that was a long video, but hopefully I've shown you practically how this works. Let me know if you enjoy seeing practical demonstrations like this of how networks actually work rather than just learning about stuff in pictures or simulations. I'm hoping that showing you how things actually work on a iOS XE switch as well as iOS switches makes it more real world for you. I really want to thank Cisco once again for sponsoring this video. Don't forget you can use the labs link below so that you can practice this for yourself and actually see how this works. I'm David Bombal, and I want to wish you all the very best.